ever crushed a soda can with satisfying ease? That simple act connects you to a remarkable story of ingenuity and transformation. Or perhaps you've reached for shiny foil in your kitchen, a staple for wrapping leftovers and baking delicious treats. Or maybe you've noticed how surprisingly light a bicycle frame can be, allowing for effortless rides and nimble handling. All these seemingly ordinary things, the can, the foil, the bike, are made from aluminum, a metal that's far from ordinary. It's a hidden hero in our daily lives, a silent workhorse that makes modern living possible. From transportation to packaging, construction to electronics, aluminum is everywhere. But aluminum doesn't magically appear shiny and ready to use. It doesn't spring forth from the earth in its final form. Its journey starts deep inside the earth, often in tropical regions, as a reddish-brown rock called bauxite. This unassuming rock holds the key to unlocking the versatile metal we know as aluminum. Transforming that rock into the lightweight, durable, and recyclable metal we use every day is a complex and fascinating process. It's a wild adventure involving giant machines that carve into the earth, extracting the precious bauxite ore. It requires extreme heat, generated in massive smelters, to separate the aluminum from the other elements within the ore. And it demands clever science, utilizing electrochemical processes and innovative technologies to refine and purify the aluminum. We'll follow aluminum's path from the mine, where massive excavators unearth the bauxite, through powerful factories where the ore is transformed into gleaming metal, all the way to the can in your hand, a testament to human ingenuity and industrial prowess. Along the way, you'll discover why aluminum was once considered more valuable than gold, a status symbol reserved for royalty and the elite, and how brilliant inventors driven by curiosity and a desire to improve lives made it affordable and accessible for everyone, revolutionizing industries and transforming society. Get ready to become a science detective, unraveling the mysteries behind this ubiquitous metal. We'll uncover the secrets behind its unique properties, from its lightweight strength to its remarkable resistance to corrosion, exploring the atomic structure that makes it so extraordinary. This is the epic story of aluminum, a metal that shapes our world in ways you never imagined, a material that has propelled innovation and transformed the landscape of modern civilization. So, let's begin our journey deep within the Earth's crust to the very source of this remarkable metal and discover the incredible story of aluminum. The incredible story of aluminum, a metal that shapes our modern world, begins with a seemingly ordinary rock. This rock is called bauxite. It's the unassuming origin from which we extract this versatile and essential element. Bauxite, in its raw form, doesn't exactly scream high-tech material. It looks more like reddish-brown dirt, or perhaps clay, certainly not like the shiny, lightweight metal we know as aluminum. Its earthy appearance belies the valuable resource hidden within. And this humble-looking rock is named after a French village, Les Baux-de-Provence, where it was first discovered and identified as a unique mineral composition. This small village unknowingly gave its name to the world's primary source of aluminum. It's the main source of aluminum, the very foundation upon which the aluminum industry is built. Without bauxite, the widespread use of aluminum in construction, transportation, and countless other applications would simply not be possible. But bauxite isn't a pure element itself. It's really a complex mix of minerals, primarily composed of aluminum oxide, also known as alumina, along with other impurities like iron oxides and silica. The concentration of alumina is what makes bauxite so valuable. The aluminum within bauxite is not in its metallic form. Instead, it's locked tightly to oxygen atoms, forming a strong chemical bond. This bond is what gives alumina its stability and resistance to corrosion. This combination creates a tough compound, requiring significant energy and specialized processes to break apart and isolate the pure aluminum. The strength of this bond is both a blessing and a curse. Bauxite deposits are predominantly found in tropical and subtropical places around the globe, like Australia, Brazil, Guinea, and Jamaica. These regions provide the ideal conditions for bauxite formation. This is because bauxite is formed through intense weathering and erosion of aluminum-rich rocks over millions of years under warm, humid climates. The rain leaches away other minerals, concentrating the aluminum oxide. Its color is surprisingly variable, ranging from a creamy white or yellowish hue to shades of tan, brown, and even a rusty red. These color variations offer clues to its mineral composition. The reddish tones are a direct result of the presence of iron oxide minerals within the bauxite. The higher the iron content, the redder the rock will appear. Geologists play a crucial role in the aluminum supply chain as they are the ones who search for bauxite deposits. They use various techniques, including geological mapping, soil sampling, and drilling, to locate and assess potential mining sites. This exploration is necessary because pure aluminum never exists alone in nature. Its high reactivity means it bonds instantly with oxygen in the air and water, forming aluminum oxide. That strong bond, while a challenge to break, is also what protects aluminum from rust and corrosion, making it such a durable and valuable material for countless applications. But this inherent stability also makes extracting pure aluminum from bauxite a complex and energy-intensive challenge. It requires sophisticated industrial processes and significant resources. To get aluminum, the first step is to dig up bauxite from the earth, often through large-scale open-pit mining operations. This extraction process can have significant environmental impacts if not managed responsibly. Once extracted, the bauxite ore undergoes a series of industrial processes to separate the alumina from the other minerals and then break those tough chemical bonds to finally yield pure aluminum metal. And so, the journey of aluminum, from its humble beginnings as a reddish-brown rock to its ubiquitous presence in our lives, all starts with finding and mining this special rock called bauxite. Once bauxite is found, mining begins usually with surface mining. Since bauxite is close to the surface, crews clear away the topsoil, saving it to restore the land later. Giant machines scoop up the bauxite and load it into massive trucks. At the processing area, crushers break the rock into smaller pieces, and it's washed to remove clay and sand. The clean bauxite is loaded onto trains or ships for a long journey to a refinery. These refineries might be thousands of miles away, ready to start the transformation. The rock beneath our feet is on its way to becoming something entirely new. At the refinery, the journey of bauxite truly begins. Here, raw bauxite undergoes a remarkable transformation, a refining process that unlocks the valuable alumina within. This is where science and industry meet, turning a common rock into a key component for countless products we use every day. Bauxite undergoes the Bayer process, a sophisticated method developed to extract alumina. This process is the cornerstone of aluminum production, a carefully orchestrated series of chemical reactions and physical separations. It's essentially a chemical bath that separates alumina from the rest of the bauxite ore. This separation is crucial, as it isolates the desired aluminum oxide from the various impurities present in the raw material. Crushed bauxite is mixed with hot caustic soda, a highly alkaline solution. This mixture is carefully controlled to ensure optimal dissolution of the aluminum compounds. The mixture is then pumped into giant digesters, massive steel tanks designed to withstand high pressures and temperatures. These digesters act as reaction vessels, facilitating the chemical breakdown of the bauxite. Inside these digesters, the hot caustic soda dissolves the aluminum oxide, forming a solution of sodium aluminate. This is where the magic happens, as the valuable component is selectively extracted. What remains is a residue known as red mud, a complex mixture of iron oxides and other insoluble compounds. This byproduct requires careful management and disposal. The mixture is then filtered, using large-scale industrial filtration equipment. This step is essential to remove the solid red mud from the liquid alumina solution. This process is critical, separating the valuable alumina solution, now clear and purified, from the solid waste. The clarity of the solution is a testament to the effectiveness of the filtration process. The red mud is washed to recover any remaining alumina and then stored safely in designated ponds, minimizing environmental impact. Responsible waste management is a key priority in modern alumina refining. Meanwhile, the alumina-rich liquid, now free of impurities, moves on to the next stage of the Bayer process. It flows through a network of pipes ready for further refinement. In tall tanks called precipitators, the alumina solution undergoes a controlled cooling process. These towering vessels are designed to facilitate the formation of solid alumina particles. As the solution cools, tiny seed crystals of alumina are added. These crystals act as nucleation sites, encouraging the dissolved alumina to precipitate out of the solution. Pure alumina begins to form around these seed crystals, growing in size as more alumina precipitates from the solution. This is a beautiful example of controlled crystallization. The alumina crystals, now heavier than the solution, begin falling to the bottom of the tanks, resembling a gentle snowfall. This settling process allows for easy collection of the purified alumina. The result of this intricate process is a white, sandy powder, alumina, also known as aluminum oxide. This is the key ingredient needed for the production of aluminum metal. Now, this purified alumina powder is ready for the next stage of its journey, the electrolytic reduction process. This entire process transforms a seemingly ordinary muddy rock, rich in aluminum, into a pure, valuable ingredient, ready to be turned into aluminum metal. Managing waste responsibly and recovering every possible bit of alumina from the process is not only crucial for maximizing efficiency, but also for minimizing the environmental footprint of aluminum production. Now, the alumina powder, a testament to careful chemical engineering, is ready for a fiery transformation in the smelting process, where it will finally become the aluminum metal we use every day. The alumina powder still holds tight to its oxygen atoms, so the next step is to break that bond. First, the powder is heated in a giant rotating kiln called a calciner, reaching over 1,100 degrees Celsius to remove all water. This leaves pure, dry alumina, perfect for the next stage. The powder is shipped to a smelter, where the real magic happens. Here, massive amounts of electricity will finally separate aluminum from oxygen. This is the most energy-intensive part of the process. The journey from rock to powder has required mining, crushing, washing, dissolving, filtering, and baking. Now, the stage is set for aluminum's dramatic birth. The transformation from powder to metal is about to begin. At the smelter, the Hall-Héroult process takes over, named after two inventors who made aluminum affordable. Alumina is dissolved in molten cryolite, which lowers the melting point and creates a hot, molten bath. Huge electric currents are passed through carbon anodes into the bath, breaking the bond between aluminum and oxygen. Pure aluminum sinks to the bottom as molten metal, while oxygen reacts with the carbon anodes to form carbon dioxide. The anodes are slowly consumed and must be replaced regularly. Special machines siphon the molten aluminum from the pots. The metal is sent to a holding furnace, where it can be mixed with other metals to create alloys. This process uses enormous amounts of electricity, more than some small cities. The powder has finally become shiny, liquid aluminum. The journey from rock to metal is complete. Why is making aluminum so complicated? It's all about chemistry. Aluminum bonds with oxygen so strongly that early methods, like using carbon to extract it, didn't work. That's why aluminum was once more valuable than gold. Napoleon even served honored guests on aluminum plates. The Hall-Héroult process changed everything by using electricity to break the bond, but it's incredibly energy-intensive. Smelters can use as much power as a small city. That's why they're often built near hydroelectric dams. Recycling aluminum is crucial. It saves 95% of the energy compared to making new metal from bauxite. When you recycle a can, you skip the hardest steps. Just melt and reuse. Recycling saves energy, reduces mining, and cuts waste. Tossing a can in the recycling bin really does make a difference. Molten aluminum is transported in crucibles to a holding furnace, where its quality is checked and other metals may be added to create alloys. The liquid metal is cast into huge slabs called ingots or long logs called billets. These are the building blocks for thousands of products. Ingots are sent to rolling mills, where they're heated and flattened into thin sheets, perfect for car bodies, airplane skins, or kitchen foil. Billets are used in extrusion, where they're squeezed through dies to make shapes like window frames or bike rims. Aluminum's versatility comes from these processes: casting, rolling, and extruding. The metal born in the smelter is transformed into forms we use every day. From soda cans to skyscrapers, aluminum's journey continues. The possibilities are nearly endless. Aluminum's journey from rock to high-tech material is truly remarkable. It's lightweight, about a third the weight of steel, yet strong, making it perfect for planes, cars, and skyscrapers. Aluminum resists rust thanks to its protective oxide layer, so it lasts in rain and snow or even space. It's endlessly recyclable, saving energy and resources every time it's reused. This superhero metal helps us build, travel, and explore. Next time you hold an aluminum can or ride a bike, remember its incredible story. From deep in the earth to the world around us, aluminum is a triumph of science and engineering. It's the hidden hero shaping our modern world.